Hey, what's going on, everybody? How are you doing? Happy Saturday, chat. Hope you guys are doing super good today. Yes, never mind, Delta. Get botted. Okay. Yeah, sorry about that, chat. Had to make sure we were topped off with some rocket fuel here. We're good to go. Today's stream, we're getting back into some KSP and working on improving our DCX vehicle with a roll controller, as we discussed last time. I think we're gonna check that out, see what we can do. But yeah, chat, check this out. That is crazy. Oh, and we get sound. How lucky are we? How lucky are we, chat? Stand by. Hold up. Yeah, that one. I want that one. Yes. Wait for it. Rewind. Rocket guy, you're failing. There we go. Headphone users. Oh, the shock. Oh, that was awesome. Wow. Ooh. Oh, you see it, chat. You see it wobble. That's nice. That is nice. Oh, that's so good. Going through the sound barrier. Nice. They did have an engine fail in Relight, possibly explosive. We called that out. We called that out in the live stream. Yeah, it looked like it hard started and the entire engine bell assembly just came back into the camera. A catch if this all of a sudden seems possible. Indeed, Thailand. Well, which, according to Elon, just take that with a grain of salt. According to Elon, they're going to be testing a tower catch next flight. Whether or not that's true, that would be crazy. Because, well, they don't even have their second pad up, so God forbid this thing just crashes right into the tower, then they're out of doing any more flight tests for a while. But anyways, you know, it could, you know, SpaceX is doing crazier things, obviously. They also were running on 2 engines for about the last 2 seconds of the landing burn. I did see that as well, yeah. Indeed. Like right on, right about here, they shut down to 2 engines, and then it just sat in the water, chat. Perfect. That is a true soft landing. I don't know what Starship did. Starship, I wish we had a view like this for Starship, because I swear, coming in on re-entry, that thing was on fire. And I don't mean like re-entry heating, I mean like after it got through the hot stuff, you could see all the lighting effects on, like when it was around 10 kilometers altitude. I feel like the vehicle was on fire. Part of it, at least. Some of the maybe the insulation was burning off, but so it can be reused. This one will not be reused. I have no idea what the state of this vehicle is. So it landed in the water, it tipped over. It's probably okay, but it's also sunk by now, because I don't think they had any assets in the area to recover it. This has just happened to be a buoy, or was this like a SpaceX placed buoy? Or was this just a buoy that had a camera on it? But it seems to be tracking, so I would assume this is a SpaceX buoy of some sort. Per an interview with Ellie in space, they're gonna look at the data and have a discussion about it before giving the go-ahead. Yeah. But it's kind of crazy to think that Elon was like, yeah, you know, it could be next flight. It's like, oh, okay, yeah, that's awesome. Let's just go from 60 miles an hour to 60,000 miles an hour like that in between 2 flights. I heard they aren't going to recover either of them, which seems odd. Well, I mean, they're sunk, right? I mean, probably. Or at least they're not in a good spot. So yeah, I mean, there's not much to cover. So they were going to open the vents to sink it, and if that didn't work, then the range boat would go and shoot it with firearms. Awesome. Awesome. I want to see the second one, please. I would like to see the second option, just, you know, out of my curiosity, I suppose. Yeah, let's just go out and shoot super heavy. But that's awesome. That's really cool. If you guys didn't see, we have the entire stuff on YouTube and the VODs. But what a great flight. Great job by SpaceX, of course. Going for the first, I mean, like going from flight 3 to this is just absolutely crazy, right? Like flight 3 had everything go wrong for like landing burn of super heavy, and then of course for Starship going through re-entry. This time did everything like Not perfectly. Obviously, they had an engine trouble on both the launch ignition as well as engine trouble on the landing burn ignition. And then, of course, Starship had the flappy wing. Starship started to have a lot of burn through, so the TPS still remains to be desired. But all in all, pretty fantastic turnaround. Oh, I was saying, Thomas, that I would like to see the second option. I just out of my morbid curiosity, I would like to see a video of somebody shooting super heavy. The little flap that could, indeed. It was hanging on for dear life, indeed. But anyways, chat, absolutely awesome. Really cool to see the landing from a different perspective, which is, that's so good. So good. Yes, and retweet. But anyways, chat, shall we get into some Kerbal Space Program? The little flap that could. That is a great title for that flight. It honestly begs the question as to what happened to the other flap, right? Because the other flap actually had the camera on it facing backwards towards the aft flaps. We never got picture from that one again after a certain point in entry, right about the time of burn through on the other fin. So I'm wondering if like that fin just was completely demolished as well. Either that or the camera definitely got demolished, I guess. Hey, what's up, Ben? How are you? Watching things like that never gets old. You said it. You said it. All right. The fun fact about the boat used for range support, it was also contracted by Blue last year to fish their fairing during testing. Oh, nice. That's cool. Good old rocket fuel chat. Alrighty then. So, this is our DCX vehicle. We're gonna put it out on the pad because we got some more testing to do. Actually, you know what? Maybe before we even do this, let's actually open up and get our I-2-107 out. Yeah, let's get this little guy out. And let's go ahead and probably put Dr. Longballs in there. That is, we are not launching it from the pad. I tell you what, chat. Let's get Dr. Longballs in there. There we go. Longballs Kerman. He's going to be our test pilot here, and we're going to put it on the runway, and then we're going to write some code here in Python to test our roll control. So the whole point here, right, is exactly like Starship, like we saw in the flight test a couple days ago. Our DCX vehicle, which is supposed to be a suborbital crew test flight vehicle, is designed to go up to a certain altitude, then pitch over, belly flop down, get near the pad, verticate, and then land propulsively, right? Just like Starship, in terms of that sort of like operation. But it also picks up a lot of speed when it comes in during re-entry, essentially, because it goes above the Kármán line. And so because of that, sometimes we overshoot the pad, and this thing is only essentially using RCS to control. And the control that we have right now is basically yaw control and then pitch control. So we don't have any roll control. It's basically commanding level wings during the entire descent. And so what that really means is that we might be turning into the wind with yaw, right? But we're not rolling into it to be able to turn effectively. So I want to implement a roll controller that basically rolls the aircraft into a turn to try and improve its accuracy during landing. That's what we're gonna try and figure out today. I'm sure all of them got as beaten as the one we saw. Indeed, I would probably expect so. Indeed, I would love to also see the aft flap condition. Like if we had a camera pointing at the aft flaps, I would like to see like how much of them is left, because they're much bigger. And so typically speaking, you can, because the nose, right, is that concave shape, the bow shock that you have going through re-entry can actually get into the wings a little bit better than if you had like that brunt body of the cylinder of the actual fuselage of Starship. So maybe the aft wings actually survive better because the forebody, because you know Starship kind of comes in like this, so the actual fuselage of Starship can push the boundary layer away from the winglets. Maybe the winglets, the aft wings, the aft flaps actually survived. I don't know, but it'd be interesting to see, that's for sure. I'm designing a launch pad and small sat launch vehicle, got all the way to integration fuel and launch and realized my root part was a docking port on the side from when I was integrating the TE. Yes, indeed. Oh my god, that's why, Dad, I had to actually implement a checklist. Let me see if I can't find standby, open file location, I2 orbital mission. So this is our previous career modes mission log, and if I'm not mistaken, yeah, we created a checklist for our pre-launch vehicles, for all of them, for our human rated missions as well as just our payload missions. And so you can see it's like control from here, make sure the proper control point is the probe core. You can change that effectively by changing the naming priority of your craft to be from that probe core. We have an entire checklist on like what to do in our career mode. So I actually probably want to do something similar for our career mode here because we're using the same code, and so there's a lot of things to like remember for each mission. It'd probably be good to implement this for our current career mode as well. It would be weird that only one flap melted. Just depends really. But yeah, it would be it'd be like, why that one? What happened to that one? You can definitely see, and we showed this during the live stream, you can clearly see tiles literally breaking off of the starship flap before burn through. So you can clearly see that some of the tiles broke off, and then later we had the burn through, and then like the whole wing separated, right? All right, let's go ahead and get our code base up. And I think what we want to do is go into our test. Yeah, so this should be our test script here. And basically what I want to build out here is the very minimal requirements here so we can actually figure out the correct role control. Because what we're gonna have to do is we're gonna have to get our heading, we're gonna have to find the error in our heading, and then our role controller is gonna have to try and have a set point of 0 error, and then have our heading error dictate our role control. I think that's how that's gonna have to work. So let's go ahead and do this. It's gonna be test role control. And then we'll come all the way to the bottom and implement a new function. And then we need con and vessel. Hopefully in that order, right? Con vessel. Good. All right. So there's a few things that we're obviously going to have to get here. One is probably going to be the landing site that we want to use because we have to be able to track it. I think we have that here somewhere. Landing site, we should have it. There it is. We have that, which might be fine. Do we have another one here that we were using during testing? I feel like we definitely were. Oh, I know where one is. It's in Falcon 9, right? Falcon 9 should have the landing. I swear, chat. I swear we had one. Where do we have? Oh, there it is. Okay, I'm just blind. I'm just blind, chat. There it is. Yeah. So we get our landing site. That's going to be our target. Do you think they can fix that just by changing the flap position? I don't think so. Because, I mean, the flaps were generally up throughout the entire reentry profile for the most part. So I think that would be the position that would have the least amount of load and probably heating as well, because they're they're folded back. So I think, yeah, I don't know. I think it'd be tough to say. I think they definitely need to just figure out their TPS issues more. Oh, that'd be pretty crazy, Thomas. Okay, good. I'm hoping so. This is on Discord. No, I'm sorry. This is on GitHub. Yeah, everything that you see here should be on GitHub. The link should be in the little info panel below. Didn't teach them enough to have plasma get into the hinge. Yep, that is true. But hey, I mean, like, for the most part, apparently one linkage severed but it was enough to maintain its structural rigidity, and it was still able to flap, which was crazy. Just when it then verticated and was under the deceleration loads of the rocket, you can clearly see the flap right is supposed to go this way, and then the flap just immediately went. It actuated in the wrong direction, indicating that some linkage was in fact broken, which is unfortunate, but you know, that stuff happens. All right, so let's go ahead and figure out exactly what we're going to need here. I probably just need to get some of this stuff here, because this is the same code that we're trying to like update. We're probably going to want current position and heading. We're going to also have to define a roll controller. So let's get those. And I think that should be all fine. Okay. We also need a while loop. I think we can do that just like we did up here. Just get the while status and then get the status time. Because I just want something that runs so we can actually check and make sure that we're getting the correct calculations and whatnot. I don't care about any of that. I don't care about start time. So yeah, while the status is in effect. Good. That hop hinge point borked as well. Yep, indeed. It was a wild ride of emotions, chat. I'll tell you what. A wild ride of emotions. All right, so we have actually the current position and heading probably need to be actually in a while loop, right? Because we're going to need to update that at every point. All right, something like that. We're going to need to implement our roll controller. So let's go ahead and do that. Roll controller is going to equal PID.PID. And we'll just do a simple proportional, I think, right now. Or maybe even like a proportional derivative. So then I is going to be 0. And then let's do 0.1 for the derivative. We need a minimum output. Let's do 30 degrees roll, maybe. That might be too high. Maybe 20. And then negative 20, or then positive 20 for the max. And then I think we should be pretty much okay. The deadband, I mean, we could do a deadband. Deadband of like, say 1. Yeah, maybe a deadband of 1. So deadband is basically saying if we're within 1 degree of our error, then don't do anything else. Like just, you know, don't keep updating the roll control condition. Okay. That I think is fine. Now we need to have our set point. So roll controller dot set point, which is basically our condition that we want our controller to meet, right? So a controller basically is it has a transient response and it has some sort of condition it wants to meet, right? And so it's going to go up and it's going to try to follow that that input. That's what our set point is. That is the condition we are trying to track here. And I think that's going to just be a error of 0. I think we could do this with error. I think we're going to do this with error. I think that's totally fine. All right, so we have current position and heading. We're going to need to get our actual heading error, and we're also going to need to, so that means that we're going to need our current heading, right? Because our roll controller is going to be based on the difference between our current heading and our desired heading, right? Because that's going to create an angle, which is going to dictate how much yaw we need, which is going to dictate how much roll we need. So current heading is going to be vessel.flight. Heading, I think it's just going to be that. My thought is that roll function should be thought of independently from yaw. Most craft get an induced roll from yaw. If there was some way to get the roll force induction, it would be nice to think ahead to that issue. I was thinking about that too, Eukerman, but I think we're okay here only because our vehicle that we're going to actually be implementing this for doesn't have like wings. Its lateral stability is like non-existent. So essentially it should not have much of an actual adverse roll effect from yawing because it's a rocket, and the rocket doesn't have any wings, which is where you can get some of that roll instability, that lateral instability. So I have thought about that. I don't know. We might have to decouple it, but I'm hoping that we don't, because then that just simplifies the whole issue. But yes, that is something good to definitely keep in mind. All right, so now we need to get from that our actual heading error. So our heading error, so it could just be a simple subtraction, but also remember that heading is bounded between 0 and 360. Do I actually have a function for this somewhere? Math utils? No, it's not going to be in math utils. Not in plotting. Maybe steering logic? Compass heading? No. Average sign. Compute heading error. Yeah, okay. So error is going to be the target heading. So we need the target heading minus the current heading. So current heading, then target, and then our error is, okay, that makes sense. So current and then target. So we're going to have steering. Yeah, okay, steering, and then heading, compute heading error. And then we want our current heading, which is going to be called current heading. And then we need target heading, which is going to be our heading. Yes. Okay, that should be good. Is this KOS or custom control set up? This is custom control. So we're implementing it in KRPC, is both the Python package and the in-game mod. And so we can use Python to control our vehicles in the game. Yep, and Delta got that covered. All right, so now that we have our heading error, we need to figure out our roll input based on that, right? So our roll input is going to be equal to our roll controller dot update. It is like that, right? Dot update. Roll controller dot update, and then just our current. Yeah, okay, cool. So this would then just be our heading error. Okay, well, that seems good. I think that seems good. You might want to do some print statements, like we did up here. Wherever we put those, yeah. Actually, let's just go ahead and copy this, and we'll bring it down here, and then we'll see what we actually want to do. So what do we need? We're gonna need to definitely print out our heading error. So let's actually do our heading first, and then our current heading. Okay, and then we're going to do our heading error. Just want to make sure all this is, of course, working appropriately, and then we might be able to do our roll input. And then I don't think we need this one for now. Okay, ideally that should work, right? Ideally, that should work. Ooh. Oh, that would actually be, Let's actually, because we can get the heading error in game, heading error, the other thing that I think would be great is to actually get our roll, like the vehicle's actual roll, so we can make sure that the direction is correct. So this should be vessel.flight roll. So this is going to get the current roll of our vehicle, so we can actually check which way we're basically the sign of our control input, right? Because this might need to be negative depending on how the calculation comes out. Might need to be multiplied by -1. So let's go ahead and try that out. So bring that over here for a moment, and let's get going, shall we? All right, and we're up and rolling out. Yo, what's up, Daves? How are you? All right, and we're up and throttling back. So if I'm not mistaken, I believe with those coordinates that we're targeting, this is going to be our target. So this is going to be what dictates our heading. So yeah, let's kind of go away from it and just make sure that that works, and then we'll hit go and see what happens, see what starts printing out. All right, so let's shrink that a little bit so we can kind of bring it here. All right, keep slowing down. Whee! Yeah, just pulling a few G's. Don't worry about it, chat. It's all fine. You know what? I think we need to pull even more G's, I think is what needs to happen. Yeah, there we go. Get that tight turning radius. Fly this massive aircraft like a fighter jet. Let's do it. Alrighty then. So, now if we come back over to here and hit go. Wait for it to connect. Uh-oh. Up there it goes. All right, so heading of 276, we are 3 degrees off, and we are commanding a roll. All right, so let's actually now go this way. So we're going to want to roll in that direction, because this is going to be our indicator. So we want 20 degrees roll. So what are we at right now? Ah, see, the sign, I think, is opposite. Because it's saying to roll right 20 degrees when I'm pretty sure we need to be rolling into the turn here to come back at it this way. Let's see if we're actually making sure that we're lining up with that pad. Yeah, see, now we're only 3 degrees off of our desired, and it's saying -5. We are -5, but it should be positive because we're going away from it. Yeah, okay, cool. So let's stop that. And let's do -1 times that amount, and let's try it again. That should be all that we have to do. How much can a rocket launch company try that out before money? I guess, what do you mean, Benjamin? Like, how many test flights can they do? Well, I guess however many they have in terms of their runway, right? It's called runway for a company. How much capital do you have to use for before you get to your operation requirements? If you're talking about just in general, well, typically it's all component-based testing and simulation testing. If you're talking about like software and stuff, even the hardware, you usually do like component-based testing into like subsystem testing into system testing. So you can like integrate and do test and test and test all the way up until you fully integrate it. But then there's really nothing you can do except for fly it to get your, fully requirement. So it's saying go negative, and so that would be roll left, and that would be negative. Yeah, so that's perfect. I think that should be good. I demand explosions. Haha. Well, I hate to disappoint, but I will disappoint you. Yeah, this vehicle is very maneuverable. Let me tell you what, chat. Longball Kerman is having a good time. Maybe too good of a time. Too good of a time, chat. Too good of a time. All right, so let's go ahead and revert to... There you go. I gave you what you wanted, Iceman. Let's go ahead and get our DCX vehicle out, and then we will enter our mission mode, so to speak. Not enough thrust on that maneuver. All right, so we have our DCX vehicle, and let's go ahead and fill us up with it was all a dream, long balls. Okay, so don't you worry, it was all a dream. Yo, Combat, thank you so much for the follow. Much love to you, my friend. And this is not a replay. How dare you? All right, let's go ahead and get you know what, let's go ahead and make a couple Kerbals here. I feel like we need more ground crew, and I think we need more pilots as well, just saying. Oh, we have Ew Kerman in the house too, so we could definitely have Ew Kerman be a pilot here soon. Let's go ahead and go into Kerbals, create. Let's see, we're gonna have Thomas Kerman. You're gonna be an engineer, and you're just gonna go. And then who else do we have, chat? Who else do we have? We have Iceman. Iceman Kerman, also going to be a pilot here. That looks great. Awesome, there we go. Neat. Now let's go ahead and put it out on the runway without any people on it. That was stupid. Yeah, we got Iceman, chat. We got Iceman. And now we just need Maverick. Yo, what's up, Erudite? I hope you're doing good. I'm doing great. I just realized how genius the flappy aero surface design for Starship is. I had the COM for a test way up on the vehicle, and it was stable because the flaps out at the aft flaps tucked. Yeah, exactly. Yeah, it's great, great controllability for changing your center of mass location, or to, I guess, account for a change in center of mass location. 100%. Yeah, I'm gonna redo that. Put Kerbals in it, then we'll send it back out. But yeah. It's really, really smart, right? All right, let's go ahead and put Kerbals in there. We need grounds crew, so we're going to put Thomas Kerman in there. That looks good. So yeah, Thomas, you get in there. You get in there with Mayor Kerman. Mayor Kerman. And let's go ahead and fly it. Nah, trust, it's safe, it's fine. I would love to pilot your intercontinental ballistic science delivery vehicle piece through pieces. Yeah, 100%. Yeah. Yeah, maybe we can work something out here, right? Maybe we can work something out here. Ooh, and before we actually do this, chat, I need to actually implement what we just created into our control logic for this vehicle, since right now it's basically just in that test script, but we're good. Made to bring objects back to Earth. That is true. That is true. There's a reason he inspired this emote for my channel. That is true. Code Brown, chat. Code Brown. Have some courage, Iceman. Hey, it lived through re-entry, Thomas. Let's get that clear right now. It definitely lived through re-entry. Now, in One Piece, that's a different story, but it definitely it survived entry. All right, let's go ahead and wheel us into position. And not tip over, preferably. Skeet! There we go. There we go. That looks fine. Go ahead and implement this traverse rate, implement this traverse rate. Okay, and kick it. Yo, what's up, Rayson? How are you? And there we go. On the ground. Perfect. Now we should just be able to bring this up, bring that off, and undock. And we're gone. And we'll get these guys to a safe distance. Is that a super advanced, high-tech, brilliant, top-secret, smart, amazing mobile launch platform? Maybe. Who knows? Who knows? I can't say, okay? It's ITAR protected. Yeah, it's top secret only, Kerbal secretness. This October marks 8 years that I followed you. That makes me feel so old. But thank you for that reminder on how old I am. Anyways. All right, let's go ahead here. And we got this guy up. Let's go ahead and fill it with fuel and get our vehicle program up and running. So if you're wondering how I'm doing this, this is through a mod called Kerbal Constructs to get the extra pad here and these fueling ports. So basically I can just click on it and fuel any vehicle, which is pretty nice. We have our GG NASA logo, and let's go ahead and start implementing what we just made, but in our DCX vehicle flight software. Yo, Small Anime Tree coming in with that Twitch Prime subscription. Thank you so very, very much. I hope you're having a wonderful, wonderful Saturday. Much love to you. Ads? Really? I swear, Twitch is getting worse about the whole ad stuff. Like, it used to be like, oh, you know, an ad ran like every 30 minutes, maybe in every hour. Now it seems like we do it every 10 minutes. Had to do it to make the ad stops. Understand? Well, I'm sorry about that, but there you go. Welcome. No ad-free stream for you now. Well, what? Well, what? Let's go ahead and so this is what I want to take and implement it over, not here, but over here where we have all this other stuff implemented. Boom, boom. So first we're going to need to do is a roll controller. Do I have a good spot for that? I guess we could do it right here. So first we're going to take the roll controller because that seemed to work pretty well. We might need to tune it a little bit later, but should be okay for Meow. Alrighty then. Vessel. So we already have that. We already have that. We already have that. But we need this stuff. We need this. We need that. And we need this. And then we need. Yes. Okay. So let's go ahead and control. Copy. Move that down here. Let's do roll control implementation. I don't have current heading anywhere, right? We have current position, but not current heading. Okay, fair enough. That works, that works. And then we actually need to implement this, right? So that's going to be target roll. And then that's going to be roll input. Yeah. Is code able to adjust dynamically? What do you mean by that? Yeah, I mean, I would say it's able to do it dynamically. It's kind of what the whole point of like a PID controller is that it takes your current heading and your desired heading and it calculates all of that, and then based on where you are and stuff, it will change the actual commanded roll input, for example. So yeah, I would think so. All right, so we have that, we have that, we have that, we have that, we have that. Good. Yeah, let's see what we have. How high are we going here? We are going to an altitude of 69 giggity. Let's take it up to like 20 kilometers. Yeah, let's take it up to 20 kilometers and test that. Oh, you know what we actually need to do, chat? Hold up. Yeah, exactly, Erudite. How do you think we do a hover slam? Yeah, we do a hover slam if we go, like I said, this is all on my GitHub. I think it's under steering logic. So yeah, we have a calculate landing burn time, and we also have calculate landing burn. So essentially, this is doing all of that for our hover slam calculations dynamically. We're essentially understanding our drag, we're understanding how fast we're moving relative to the surface, we're understanding our current vessel mass and our current velocity, and we're calculating using a analytical solution, it's an approximation, when we need to start our burn in order to have us basically land a certain amount of altitude off of the ground. So yeah, it works pretty well. I have to say, it works quite well. But yeah, definitely dynamic capable. Alrighty then. I think we're good. I think that's fine. That's really cool. No wonder you work in the industry. Takes it's all fairly straightforward, but it's definitely like you gotta kind of know where to look. You know what I mean? I feel like that's half the battle for like any sort of aerospace or probably any sort of engineering, right? Like you don't necessarily have to know everything, but you have to know where to find these things. I think I want to implement that. Where was that? I think it'd be good to implement the roll controller probably here under mode 1 right before we implement. Well, I guess that actually doesn't matter if we do that or not. But I'm trying to think, do I need my set point to change it all? I don't think so. I don't think we need our set point to change. Roll by pumping fuel around. There you go. Yeah, perfect. Perfect. Something just popped into my head. What would the flight trajectory of Zogdor look like? Yeah, I have no idea, really, Thomas. I mean, it's not going, it's going far, but it's not going that far. Yeah, what would that look like? Especially when you're talking about it always moving over land. I don't know how much, like, clearance they need, right? Because, like, when you have a keep out zone for flight, how far does that extend? Because it would have to probably be pretty similar for something like Zogdor, and it has to fly over land. So I have no idea what corridor it can fly over. Because also they're going to have to probably make a new pad, because if we actually look at the let's see, Google, you know what, I need to download Google Earth on this computer. I don't have it downloaded on this computer, so we have to go to the web version, which is kind of like ugh. All right, let's see, where is, yeah, let's see, because the reason why I bring that up, right, is because we need that's Australia. We need to come over here. I'm all turned around, chat, because it, there we go. There we go. Okay, so where Maston currently is should be out in the Sticks, Mojave Air and Spaceport, which is going to be in Mojave, which is near Bakersfield, and also near, let's see, let's just find, keep going south, Santa Clara, Lancaster, there it is, Mojave. So yeah, here's the Mojave Air and Spaceport, which is where Maston Space Systems, or which is now an Astrobotics company, actually operates out of, and I believe they are right here, yeah. So, oh, this is even an old picture of it. They actually expanded on this site. But yeah, this is Maston Space Systems, which is also now an Astrobotics company. So this is where they work out of for Mojave Air and Spaceport. You'll notice that this is also a Boeing 747 graveyard. Ooh. Ooh, what's that? That looks like a Burt Rutan design. Interesting. It's a pusher. Anyways, but yeah, this is a graveyard for aircraft. Yo, what's up, Hellfish? How are you? They also have to work around the ABL test pad, indeed. I hate that north isn't up in this view. Reset to north. There you go. How about that? You good? You good now? So these are their pads, chat. So this is Mojave's, basically Mojave Air and Spaceport. They have multiple pads for different aerospace companies to test out. Why? Because they're in the middle of a desert. So this is one pad that Mojave, or that Maston owns. I think they also own this pad here as well. And then of course ABL, is ABL here for their rocket engine test pad? I think so. But anyways, so there's several pads here opened for like rocket testing and whatnot. But yeah, if this is Maston's pad, then they have to go kind of this way. Like they might be able to make that work, but yeah, they're going to be flying over other people's pads, which again isn't like unheard of. But it's kind of interesting, actually. It's actually not as severe as I was originally thinking. I actually thought they had to go more south, but no, it's actually a little bit, it's actually, you know, more west than anything, because they want to fly from essentially Mojave, which is right there, over to the Spaceport America, which is where is Spaceport America? Spaceport America. Yeah, there it is. So they have to go all the way over here to Spaceport America. Oh yeah, and there's, by the way, is Virgin Galactic's hangar. They have to go from the Spaceport America in New Mexico. They have to fly over Arizona, and they're taking off from here. So if we kind of fish this out a little bit and grab this, we have to go from here out to Spaceport America. Gosh dang it, where was Spaceport America? And let's go back to Spaceport America, see where that was. Okay, so it was actually pretty close. So they have to go from here over Arizona, almost over Phoenix, definitely probably over Prescott. Maybe they can maybe they can thin the line through Prescott and Phoenix to get there. They're essentially launching from about right here over. So from here over, which is definitely like, oh man, they're like going through, well, not quite through Phoenix. Like I said, they're gonna really have to have an accurate takeoff here. Huh. Thread the needle through Prescott and Phoenix. I don't know how they're gonna do it, honestly. Hey, Captain Failure, how are you? That's the ABL site? Yeah, okay. Does Bezos have a rocket site and a secure clock somewhere northwest? I'm not sure. I'm not sure what all what all Blue Origin has at their disposal. We know that they are also working with the United States Air Force to do stuff out at Edwards, so they might operate out of there. That's true. That's true. But even then, like, Edwards is, you know, not that far in terms of like a difference, right? Like, if they can actually work out of Edwards, that doesn't change. That moves them a little bit further south. But yeah, I'm trying to figure out like the trajectory they're going to have to fly, because you're not allowed to fly over people, chat, right? So of course they're going to have to go over an interstate, which could be arguably a not a big hazard, especially if it's far enough away, right? Like, how far is it from Edwards to 15? Let's get that in kilometers. Yeah, 71 kilometers. So that might be far enough away, since they're in the desert and not flying over anybody else. It's definitely interesting, though. It is definitely interesting, the path that they're going to have to take to come down into Spaceport America. I don't know. Yeah, they have to cross an entire state. Like I said, like at a certain point, right, you're high enough and you're going fast enough where if something does go wrong with your launch vehicle, and if they're going over a lot of desert, then having a little bit of a populated area could be okay. But like I said, it's just not something you typically do, right? I don't know. That's pretty crazy. Yeah, it's right there. Okay. From here to there. Ah, that's crazy. I don't know how they're going to do it. That is tight indeed. Blue only has 2 launch sites, one at Van Horn, Texas, and one at Cape Canaveral, Florida. No clue where the clock is. Yeah. Okay. Well, anyways, chat. No idea. No idea how Zogdor is going to operate. But they do have contracts for it. All right, let's try this and see what happens, shall we, chat? I think we finished implementing what I wanted to implement. We got the roll input in there. That should be okay. We have the set point. I don't know if I have to update the set point. I don't think so, because the set point should just try to be to implement 0 roll. And if we have our heading the same, then that should just be 0. So I don't think we need to update the set point like every loop or anything like that. So I think we're okay. So here we go, chat. Are we ready? Go ahead and save it. And let's go ahead and start our auto sequence. 3, 2, 1. And there we go. Vehicle is up. I don't know why it changed its roll orientation. Do I have a different roll set for each? Hold up. Dun, 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 dun. Oh, it's because I update the heading after we do the initial roll. That's why. I actually probably need to flip that, don't I? Because we need to go up here. Stand by. Probably want to change these, because we have roll first and then our pitch and heading. But like I said before, the way KRPC control works is that it's all based on the heading. So if we were going like perfectly vertical, it's going to have one roll orientation, and then when we pitch over, it's going to then have a different roll orientation. So I think that's what was happening. I think what we want to do for our next flight is actually take this over here like so, and then take you over here and put you like so. that I think should fix that roll issue. All right, vehicle is now coasting up to 20 kilometers. There it is. Chamber pressure nominal. Nominal, exactly. For the next 10,000 years. Brilliant. Are we just going to create this entire lore now? Is that happening? All right, we're looking good. So one thing we're going to have to check here, and this might not be a very good test because we're coming back with a whole stinking lot of fuel, but maybe we're okay. That's actually true. Nice. I like it. That sounds absolutely wild. There we go. So let's see what it's printing out, chat. So this should be our target roll and our heading difference. So it's basically commanding no roll, which is perfect, right? So now that we're having a little bit of roll, that actually seems pretty decent. Like I said, we might have to tune the controller so it's less reactive, but we're looking okay. We're now starting to go towards the towards the pad. That's our horizontal velocity right here. This is our heading error. This is our roll. This is our pitch indicator. We're pitching up. Trying to slow ourselves down before we overshoot, but it looks like we're going to probably overshoot anyways, which again is fine. I know, right, Erudite? It's good. Actually, we might not overshoot. We're pitching up, we're slowing down. We are going to overshoot a little bit, actually, possibly. But we're going to actually get into a landing configuration. Oh, it's starting to turn around, and then we enter landing config. Starting our hover slam. Okay. Wow. How about that, chat? Hover explosion? Yeah, maybe. Huh. Well, we didn't have to actually do much rolling there since we kept ourselves aligned, which is what I was talking about earlier, as this might not actually be the most accurate test. But you know what? Let's go ahead and get our recovery vehicle out so we can put it back on the pad, and we'll do this again. Yeah, now we got it ended up much higher, so we can actually get the effects that we were talking about. Because you know there's other things that we can do, right, chat? Because like right now we're basically saying point towards the pad at all times, and if you overshoot it, point towards the pad, which means do a 180. We could actually implement like a keep out zone to where basically the vehicle targets, say, a 500-meter circle, so that way it has time to like turn back around without it just doing a 180-degree turn. Like there are a lot of things that we can do. It's just a matter of how much time and effort do we want to put into this. Maybe the answer is a lot, but over time, you know, I'm certainly down. I like how the cameras get messed up. I don't understand why. There we go. Okay. Bring it up a little bit here, like that. Bring this down a little bit here, like so. And roll it back. Now we can pick it up. And there we go. Good deal. I hate this. Sometimes the landing gear gets like stuck in the ground, which is really unfortunate, but just kind of gotta maybe just retract the landing gear at this point. Yeah. Up. Or not. Or not. Let's maybe not do that. I don't know. Maybe let's not do that. Stand by. It's fine. Don't worry about it, chat. We're good. Oh, it's because it's full of fuel. I totally forgot it's full of fuel, chat. Oh my gosh. How annoying. I'm actually surprised this is not able to keep it upright, though. Stand by. Let's figure this out. Maybe. Yep, there we go. Oh, there we go, chat. Easy mode. Yeah, definitely need a counterweight, but it's because this is like fully fueled and it's supposed to come back empty, so yeah. It's fine. We did it. Don't worry about it, chat. We're good. Just gotta get some motion, some momentum going. That's all. Easy. Sketchy. Nah, we're good. Simple standard operating procedures for recovery. We're good. If at first it doesn't work, try harder. You know? Like that. Go until you break something. It's fine. Lift with your back in a jerking twisting motion, right? Alright, now to get it down. Hopefully that will be a little bit easier. But who knows? We're gonna have to go very slowly here. That way our center of mass doesn't, like, throw us out for the momentum gain. Local operating procedures, yeah. Yeah. What they don't know, what admin doesn't know doesn't hurt them. Yep, what Jeb doesn't know doesn't hurt him, so long as we got it figured out, right? There we go. That should be smooth enough. Yeah. Yeah, we're good. Don't worry about it, chat. We're fine. Okay. And we're off. There's a flagpole right there. Meme tax. That's right, Wes. Pay your taxes. And Atrox, thank you so much for the follow. Appreciate it. Rocket Guy, watch where you're going. Don't get distracted by chat like you always do. Skirt. All right. This seems like an arbitrary safe distance. Alrighty then. Let's fill it back up with some more fuel. And this time I'm going to F5 so we don't have to keep doing the recovery stuff. Yep, seems good. Sweet. All right, so this time we're gonna go much higher. Target altitude of 69 giggity, because that's gonna be a full flight test here, and I have no idea what's gonna happen now, because we are definitely overshooting the pad as we have consistently been doing. Musk has once again tweeted the next is gonna try to be catched. Well, there we go. How about that? Let's actually kick us out to 87.0 degrees pitch. And let's actually wait for a few seconds off the pad, and then we'll roll, and then we'll be good to go. Okay, it seems fine. I'm now questioning this, but we might be okay. I'm questioning this part now, but anyways. It essentially means, I guess, that we shouldn't do a roll program. Let's go ahead and Let's go ahead and start, shall we, chat? Nope, that is not what I meant to do. You hush your mouth. Come down here. There we go. Good. Oh, that's fine. I didn't want that anyways. Yeah, there we go. Let's try it. Full flight test, chat. There's our what? Why? I could seriously not tell you why that happened. Little styling moves. Yeah, something like that. Okay, well, that's slightly concerning. Yeah. I think it's because our reference frame is not correct for this right here. I think we need to be in our body reference, our reference frame, maybe. Let me try that. The reference frame. Yeah, we'll try that. But anyways, it's heading in the right direction. It's just, I don't know what that was all about. That's why I love programming. Indeed, you change one thing and then everything breaks. Yeah, great. I think it's beautiful the way it launched. Oh, I'm glad. A little pirouette off the pad. A little pirouette off the pad, indeed. All right, should see shutdown here around 70, 71 kilometers. 72, 73. Seems okay. And let's go ahead and coast up to Apo. It's not a bug, it's a feature. Exactly. With Booster 11, I think all the fire was methane residuals from 9 shutdowns. Oh yeah, for sure, 100%. 100% erudite, because we've seen that on like shutdowns for like static fires and stuff. Yeah, it's basically them purging methane, and because it's not under thrust anymore, the methane just kind of pools, and then instead of actually having combustion, it just conflagrates, meaning it just, you know, combusts slowly. So yes indeed. That was my thought as well. All right, about to pass Apo. And rotate. So now it should get aligned with the pad. There it goes, aligned with the pad. Very nice. And now we wait, chat. And now we wait. So how far away are we? Ooh, 5 kilometers. Ooh, spicy. We are 5 kilometers away from the pad in terms of our horizontal downrange distance. And we're moving further and further away from it every second, so there you go. A slight leak due to one of the engines like going pop. Oh yeah, that's true. Yeah, definitely the pop was pretty strong. All right, looking good. Keeping an eye on our pitch authority so we can turn our RCS on. So could the acronym RUC work? Random Unplanned Conflagration. Yeah, I think so. Yeah, a RUC. We're stuck in a RUC, chat. Okay, we're looking good. Just checking that pitch authority when it starts to max out and stay maxed out. Let's go ahead and turn our RCS on. Looking good. How are we doing pad wise? 7 kilometers away. We might not actually make it back on this one. We'll see. Yeah. All right, we are now moving towards the pad very fast. Yep, we're going very fast towards the pad, but now we are spinning around because why? I don't know. All right, moving away from the pad now. Aerodynamics, stop it. Sometimes this happens because the aerodynamics overload the vehicle. Okay. Moving back towards the pad. It's going pretty good, actually. During flight test 4, indeed, 100%. I'm surprised we're not pitching up. I guess that's because we're still really far away. There we go. Now we're starting to pitch up. We're trying to slow down, chat. But we're gonna end up overtaking the pad again, I think, because we are not slowing down enough. If it corrects, that'll be impressive. It does correct, but then we're gonna overshoot and it's gonna have to do another correction here. There we go. Overshoot, head back towards the pad, pitch down. At least the roll seems to be doing good. You see how it's rolling? That's actually really nice. Looking okay. Looking okay. Now we're getting into landing config. Stand by for hover slam. Hover slam has begun. I mean, it's not bad. It's not bad. Going up to 73 kilometers and then coming back to the pad within 370 meters, I'm happy with that. A lower limit for when the craft changes position? Yeah, could be. We could do like a 1.5 kilometers. We could try that and see if that's going to be fine. Let us see, where is that implementation down here? Impressive, well, thank you. Yep, not bad, just for some simple PIDs in the control loop. Like I said, what I really want to try eventually, chat, and maybe that'll be a project in the next couple of weeks, is implement like an augmented proportional integral controller for navigation. It's actually called augmented proportional integral navigation. So maybe we can do something like that, because then that should be way more robust. That's the kind of guidance that actual missiles use. And if you've ever seen missiles, right, they track a target for intercept. And that's kind of what we're doing, except our target is a landing site, and our intercept is, you know, we want to be vertical when we intercept instead of like going straight in for a nosedive at intercept. So there's some similarities that we could probably implement for a good little bit. New Shepard still has the best landing burn. It does. It truly does. Wonder how long before Elon tries to land both stages of Starship. What do you mean? I mean, he's already done that. Or do you mean like back at the pad? That I have no idea. Something that seemed really interesting about the damage of Starship flaps took is how localized and around the cutout was. Relatively speaking, it was a small area like the plasma ball balled up in that pocket, then punched through because the pressure was too high there. Yeah, probably. Something like that. I mean, you can clearly see on the video, at some point before the burn through, tiles were literally popping off of the flap. You can clearly see that very, very well in the video. In fact, I think, let me see here. If I go to x.com, I think I retweeted some pictures of it. Let's see, go here. Go to likes. Yeah. Yeah, here you go. Yep, you see that right there? That's a tile. That's a tile that came off of the that came off of the fin here. And there were more like this as well. So yeah, tiles were definitely coming off 100%. Which is not great, Bob. Which is not great. You can tell because of the way it is. Yeah, indeed. We all watched the SpaceX X video. Yeah, indeed, we did. Chad is going to need to get their ITAR certification soon, indeed. Yeah, they are apparently going to try to catch a booster next flight, but both? I don't know. Like, I don't know how many flights Starship needs to have before they're like, yeah, you know what, we can do that. Because this, although a great success because they actually did do a soft water landing, not a great success if they wanted to like try and land this thing back at Boca Chica or whatever, right? Like that's not great. But you hate to see this, chat. That shot is crazy. It is. It truly is. But anyways, yeah. So what we wanted to do, chat, is figure out a lower altitude by a little bit. We're at 2,000. What happens if we're at 1,500? Yeah. 1,500. The other thing that I wanted to do. What's your top 3 favorite cheeses and why? Ooh. Okay, I am a sucker for like goat cheese. That on top of like bruschetta or something, absolutely fantastic. Especially when you have like recently I found at Costco fig infused goat cheese. Oh, it's sweet, it's tangy, it's fantastic. That 100% number 1. Number 2, when I'm feeling something probably a little bit more casual, probably something like a good pepper jack cheese is really good. Little bit of spice, it melts really well, kind of goes on just about anything. Pepper jack's pretty great. And then let's see, a third, I really like a good sharp cheddar. Oh no, blue cheese. There we go, blue cheese. 100% blue cheese for number 3. Goes good in salads, goes good on dressings, goes good on burgers, in burgers. Yeah, blue cheese for number 3 for sure. So yeah, there you go. So goat cheese, pepper jack cheese, and then blue cheese. Curious if you have considered showing live telemetry graphs for the flight software using something like Grafana. We have not done Grafana, but we do have data streams. I just turned them off because having them pop up every time we test is kind of annoying. But yeah, you could certainly, we could definitely do it. How about we do that for the next flight? Yeah. Ooh, Asiago is good. Asiago is really good too. Yeah. But was the tile coming off due to burn through at the hinge point, or because the vibrations and such of re-entry? This was before burn through actually occurred, or at least it was before we could see the burn through effects. So whether or not one came before the other, it's hard to tell because we can only see one side, but there were some massive flashes and explosions before we could see any burn through, right? I even pointed out in my live coverage of it that it wasn't looking great. It really wasn't looking great for quite some time, and then all of a sudden, you know, the fin started disintegrating before our eyes. All right, let's go ahead and roll back. What was that? The alert just went off, but I don't see it in my feed. And I didn't catch it. I don't know what that was, what that was, or why, but not sure, chat. I don't know what that was. All right. Nope. 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 I have no idea how far back we just went. I thought we F5'd right before launch. Did I not hit the button correctly? I love that EJ was so shocked by that he dropped the S-bomb in front of 2,800 viewers. Nice, right on. At which part was he shocked? Yeah, indeed. Yeah, I lost my as well in 2 points. Definitely booster landing at the hot staging ring separation, at the plasma views that we got, and then at the burn through that we got, and then at the landing. Yeah, like every time just like blew my mind. I was screaming at chat. Oh, when it splashed down, indeed. I still say that Starship was on fire at around 10 kilometers altitude because yeah, absolutely, DJ, my pleasure. My pleasure. Even if the steel is not actually melting, how hot can it go under high aerodynamic pressure before sustaining permanent structural damage? Yeah, I don't know what the design loads are for that. It kind of depends. Oh, there it came through on my activity feed. Oh, DJ, that was you coming in with a Twitch Prime sub. Much love to you, my friend. Thank you, thank you. Apparently the alert... Wait, no, it just went again. Was that you, DJ, before? I have no idea what's going on with the alert sequence, but there you go. I appreciate it. Thank you so much for the Twitch Prime. Much love to you. Alrighty then. So, yeah, I just wanted to revert because I have no idea how far back we ended up reverting, and that was not my intention. So, let's go back to Spaceworks and get back to work. I chucked you $2.99 and a Prime? Well, much love to you. Holy cow, what did I do? Stop it. Thank you, though. That's actually crazy. Much love to you. Much love to you. Why do I not have... Oh, I know why. Because I am slacking, chat. That would be why. I mean, what else is new, right? No, not there. I totally forgot to open up my stream alerts. I think that would be the reason why. Yeah, there we go. Thank you very much. Shocker, Nolan is slacking. Indeed, shocked Pikachu face. No, oh, it actually did a quick save at this point. Are you kidding me? Oh, that's so annoying. Okay, well, I guess this is the way, chat. Let's go ahead and recover. Hi, thank you, DJ. Much appreciated. Much love to you. Charitable, considering the goat cheese answer. Wow, you're not a fan, huh? Goodness. Okay, then. My bad. I didn't know that you felt that strongly about it. Learning something new. Not an Alien has some very strong cheese opinions, chat. Goodness, I guess you can be beat down for anything these days. Wow. Crazy. Did we at least keep our herbals that we made? No, we didn't. Oh my gosh, are you kidding me, game? Why you gotta be like this? What did you do? Benjamin coming in. Holy crap. What did you do? Gifted. Well, welcome, Aquilux, Shortline, Magister, Pigeon, Chief Engineer, Urban Venture, Buzzcat, Dingo. Oh, great name, Dingo. You know my original Xbox Live name was a Mighty Dingo. I think we're on the right thing here. Forfa coming in, and then also Hyper. Dude, much love to you. Holy cow. Love the goat cheese. Well, at least somebody does. Good. I'm glad. Goat cheese is greater than most cow cheeses. Wow, okay. I'm glad, you know, we're bonding, chat. You see, we're bonding. We're bonding over goat cheese. Hell yeah. Not what I was expecting on the stream today, but I am here for it. All right, Thomas, Kerman. That looks fine. Not that, though. Nope. And then we also needed Iceman, Kerman. That was the other pilot. Yes, not that, though, but yes, also actually randomized. Oh, wait, why? Interdasting. Yes, Benjamin coming in with 10 gifted subs. Good lord. Why, thank you. Much love to you. High five, all that jazz. Yes, all of the sub alerts are now going to go off. And yeah. Does it automatically read? No, okay. Well, that's fine. I hate that random only does random name and not like anything else. It's kind of annoying. Oh my. What's up, Buzzcut? How are you? So yeah, this is going to be Iceman, and that seems fine. Perfect. Done. And so now we need to come over here. Let's not have click through. Close that out. Then we need oh yes, to go here and then to go back here, and then we need Thomas. Yes, good. Thomas is going to have this and not that. Good. Alrighty then. You and Mayor, that's who it was. Perfect. Okay, let's try this again. Yeah, chat? Try this again. If this was real, the military would shower you in point-to-point cargo contracts. You know what? Damn right here tonight. Yes, indeed. That's right. That large defense budget coming in for some Kerbals. That's right. Kerbal government is really liking what we're doing right now. I hope that Kerbal has a rocket landing on him. On Thomas Kerman? Okay, good. Yes, great, wonderful. All right, let's bring this back out and we'll do another flight test here. All right, looking okay. We'll head off to the pad this way and hopefully not tip. Yeah, we're not going to tip. That's right. God, I need to get the bigger wheels, chat. We got to upgrade our research facility though. We're maxed out on the current research that we can get in terms of the tier. So for whatever reason, the medium rover wheels are at the highest tier, right next to the super large rover wheels. I don't understand how that works in the stock game tree mechanics, but yeah, not great, Bob. Go ahead and do that. Bring it down to about there. All right. See, when it's near empty, it's totally fine. I know, right, Thomas? True. Oh, I forgot to put the, don't worry about this, chat. Don't worry about this part, chat. We skipped a part in the checklist. It's fine, though. Okay, it's totally normal. Totally normal. Bring that in, and prodigious. And we're off. We're off to the races, chat. Yeah, we'll just keep that up vertical. It's fine. Have you and EJ ever thought about doing collab streams together? Yeah. I think it's something that kind of needs to be, I guess, not only thought about more, but I guess asked for by the viewers, right? Because it does pop up every now and then, but it's like, is that really what you guys want? Who knows? Who knows? But yeah, I'm certainly down for it. But EJ's a busy guy as well. All right, that seems good. That seems good. We need to refuel it. That would be important. Probably F5 here. There we go. Quick save. Let's make it happen. Actually have a streaming schedule. I do have a streaming schedule. How dare you? Monday, Wednesday, Friday, and the weekend when I can. And the weekend whole thing, you know, for like EJ collabs is fine because he doesn't even stream on the weekend. The multiplayer update? Oh, wait. Ooh, too soon. Too soon. Is that too soon? I don't know. Maybe it's not too soon. We did not bend the bells. No, we did not. We did not. Totally did not. Totally fine. Everything about it is fine. We're quick saving. There's like the 5th time we've quick saved. It has to be there, chat. And what did we change? What did we change here? I don't think we changed anything, right? We're just testing again for repeatability. Because what I would really like to do, chat, is now start using this to do some suborbital flights with Kerbals on board, so we can get them up and experienced for them to then go into space. That's kind of what I think I would like to do, question mark. Also, we do need to figure out what we want our manned vehicle to be in this save. We have several to choose from. We have the Kerbal Crew Return Vehicle, or the CRV. We can always build a capsule like the Dragon capsule or Starliner. There's also the Space Shuttle, although I don't know if I want the Space Shuttle to be our first crew vehicle, but it can be. We have like the CAD V. We could use this thing on an as like the upper stage for one of our vehicles. There's a lot that we can actually use that we already have kind of made to be our crew carrier into low Kerbin orbit. But that's something for us to decide on. We have 2 different types of shuttles too. We have the STS orbiter and we also have the Dorito, right? We have the massive Kerbal Clipper, which is just the triangular the triangular vehicle. The actual I2 shuttle, this guy. We have that as well. So There's a lot to choose from. A lot to choose from. Okay, well, let's see what we can do, chat. That seems all good to me. We're going up again to 69 giggity kilometers. Yes, we are. Perfect. And go. Let's see what happens, chat. Let's see what happens. Three, two. Oh, this is also going to be really weirded out, isn't it? Yep. Huh. 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 It's not great, chat. It's not great. Why is it doing that? Okay, so it hit this. It checked. Oh, it checked active stage. I need to do the control after that, don't I? Wait, don't I? Do I not? From here? Uh-huh. Well, that'll do it, chat, I think. One second, chat. Starship is great success. Let's go to docs KRPC. And I would like for it to be control. Could be flight as well, actually, but let's see. Brakes, antennas, intakes, parachutes, abort, input mode, forward, yaw, roll up, right, keys, custom. No, so it's not that. Is it flight? Or autopilot is probably what it is. Yeah, blocks until the vessel is pointing in the target direction and has the target roll if set. That's what we need to use, chat. We don't need sleeps, we need weights. That's what it is. Yep, okay, good to know. Iceman needs coffee, yeah. Yeah. Corkscrew flight plan, something like that. The Fuji concept? Yeah, we actually made that in our last save too. It's another one that we could do. The FTS button. It's fine, don't worry, it'll come back, I promise. Yeah, slightly scary, slightly scary. You made the pancake? Yep. Sure did. Yeah, I have to see if it's I don't remember what we called it, but I know we made that concept at some point in the it's probably years ago now. With the drop tanks, like the separate propulsion module and stuff. Yep. All right, so how far away are we? Yes, 4 kilometers in opening. Distance to the pad. Our pitch because of their distance to the pad. Our pitch because of our horizontal velocity from the pad. Our heading error, and then our roll commanded roll due to our heading error. That should be what our printouts are. All right. And now we chill. We're just now entering the atmosphere. So yeah, it seems like we need to implement weights and not just sleep. Dun, 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 dun. So yeah, how do we implement that? Blocks until the vessel is pointing in the target direction and has the target roll if set. Throws an exception if the autopilot is not gauged. So can we do autopilot.wait then here? So vessel.autopilot.wait. And then we shouldn't need that anymore, and then do target roll. And then again, do vessel.autopilot.wait. Something like that. But also, maybe we need to check our active vessel and our control point before all of this. Yeah. Oops. All right, stay in control. Come on, stay in control. You can do it. I believe in you. Come on, DCX, recover. Oh, this is less than ideal. Let me tell you what, chat. Less than ideal. It cannot recover from here. It is trying so hard. Up, up. Come on now. You got it. You're getting there. Up, up, up. There we go. There we go. Okay. Whew. What a ride. What a ride. So would any sane operator say that 50,000 meters and 4,000 away we need to slow down? Yes. Depending on the flight dynamics of the vehicle, absolutely. So how are you streaming to YouTube at the same time? Instances of OBS, or can you have two stream keys in the one instance? Two stream keys in one instance with a, there's a OBS add-on for like multicasting or like multiple output or something like that. Oh wow, look at us, chat. We are just cruising right now. Yeah, okay. But yeah, that's how we're doing it. All right, we're gonna pass over it again, unfortunately. Uh-oh, and we're about to go into landing configuration. Not good, chat. We're gonna go really far away this time. Come on, get back to the pad. All right, and flipping into landing mode, question mark. Hopefully, okay. Oh, God. Okay, we're vertical. We're vertical. Okay, we're fine. And hover slam, hover slam. Okay, we're good. There's some trees here, but that's fine. There's some trees here, but we're okay. Whew. We're fine. Just like the real thing, chat. Just like the real thing. All right, let's see. So yeah, like I said, we can see some plots here on what we did. So this is after apoapsis. You can see at 8,000, we're just cruising, and then we start slowing down. So this is our altitude versus time. So you can see we're basically in a free fall until right here when we enter our altitude hold and then our landing. Let's see, this is our commanded throttle. So you can see once we get up to altitude, we are trying to, oh, that's actually a really nice throttle response. A little bit of an overshoot and whatnot, but it hones in. So we're trying to hold our altitude for just a second, and then we start our free fall. And then it starts calculating our required throttle response. This is actually calculated throttle response and not the actual throttle response, right? And then once we hit here, we're actually enabling our throttle. And then last but not least, we have our vertical velocity. Yep, so you can see that we're basically free falling, and then we start slowing down because we're hitting the atmosphere, and then we command our hover slam, and then our nominal rate of descent. So not bad. Not too shabby. So let's go ahead and implement the weight, because that could be good. Yeah, we definitely need to implement proportional integral navigation, I think, because that proportional integral navigation should be able to manage our velocity moving towards the pad and account for it better than what we're doing here. It should, like I said, it should. That's kind of like what it's meant to do, right? If you've ever seen missile guidance, right, with trying to track a moving target, it actually tries to compensate based on the understood velocity of the vehicle it's trying to intercept, and that is what proportional navigation is. So we should be able to implement that and have a smoother response, hopefully one that's a little bit more robust, but yeah, we'll see. Yep, proportional navigation. You can do augmented proportional navigation. You can do augmented proportional integral navigation. Yeah, there's a whole bunch of stuff. There's a big old textbook called Tactical and Strategic Missile Guidance that we can utilize. Yeah. Yep, pretty much, JM. Pretty much. And it's all relative on your rate of change too. So we're actually using rates versus just a static calculation at every time step. What was I doing here? No, I mean, I think that's fine. We just need to try and figure out how to not overshoot. That's our biggest worry. Either that, or we need to have like our target actually be kind of like a waypoint or like a keep out zone until a certain altitude. So that way it aims a little bit off, depending. we'd have to have 4 waypoints, and then based off of like the farthest one, that's the one we aim for. I mean, that would be one way to do it. It actually wouldn't be great to do the farthest one. But like based on our heading, or based on our current position, we go to the one that's actually closest, or maybe second closest, because if we go to the closest one, we'll basically be going right to the pad. If I'm thinking of the 4 like Cartesian coordinates, sorry, cardinal directions. So if we go to the one that's actually not closest, then that would give us a slightly prolonged. Yeah. There's like I said, there's many different ways to do it, right? It's all depending on just how much effort you want to put into programming it. Can I borrow that textbook? Yeah. Are you using iterative numerical methods like Fourier transforms, fast Fourier transforms? No, we're not doing anything like that. Only numerical method we're doing is like Euler integration, just very simple for our estimators. Currently, anyways. Okay, so I want to see if the wait time that we have implemented is actually sufficient. And I'm actually wondering if I need to implement more. We really could. More authority on the horizontal velocity controller. Like I said, if we just want to stick to the linear control systems that we're using, we could certainly just do that. But let's actually just go ahead and try it. Is this fully fueled? Yes, it is. All right, so I want to make sure that the autopilot.wait function is working. When I use low TWR, yeah, that's kind of like, oh, that was actually really clean, chat. Oh, that worked. That actually worked. You see how smooth that was? Okay, so what the changes we made to that seem to do very, very well. So we implemented a .wait function on our controller to make sure that it actually waited until it got into a very, very small error before it went to the next control point. So that was pretty smooth. I like it when something simple like that works. Still going to 69 giggity kilometers. Yes, that should all be fine. Yeah, so this right here, .wait, that worked perfectly. All that should be fine. Yeah, I think we're pretty much there. It's just we got to try and figure out a way to better mitigate our horizontal velocity. That's really what it just comes down to, honestly. I wonder how well we would do if we actually just, instead of using a cascading controller, just use our horizontal velocity controller, but trying to track like 10 meters per second towards the pad. And give it way more pitch authority. No, that wouldn't be good, actually. No, we do need the distance to the pad to regulate that. Because we could like pick up a really, really high horizontal velocity, but if we're really, really far away, we kind of need that, right? So we need to remain pitched down in order to maintain that so we can get back to the pad from 5 kilometers away. I kind of like where we are. We just need to try and figure out ways to better regulate our horizontal velocity, which might just mean our horizontal velocity controller should be given more pitch authority. Can you target for actual target but 5K up, and then your final stage will be coming basically straight down? That is actually another way to do it, Teague. So not necessarily that way, because right now we're basically just tracking our downrange and not our vertical, although we certainly could. But it's kind of hard to do that when we're not like actually a lifting body. But what we could do is if we get within, say, 100 meters of the pad with a certain high horizontal velocity, then just go vertical into our landing configuration. Because basically right now what we're doing is we're screaming towards the pad and we're overshooting, and then we're having to turn around and come back. But like, let's say if our horizontal velocity is greater than, say, 50 meters per second, then if we're within 100 meters of the pad downrange distance, just go ahead and go vertical. That actually might be the way to like more easily manage this. It won't, of course, be like the most accurate thing, but it'll at least probably be better than trying to turn around and do a 180-degree turn. But it sounds like an absolute nightmare to implement. It shouldn't. It kind of depends again on how you implement it, right? So for boost back burns, I think you can just implement an orbital trajectory, almost like what we're doing with our apoapsis estimator. So you can just use the orbital elements, and based on your current orbit, find the intercept point, because the intercept point can be known through the mean anomaly, right, for a given altitude at Kerbin. So like, what's that intercept point? And then you just wait for that intercept point, the latitude and longitude of that intercept point to be the latitude and longitude of your pad, or of your target landing zone, right? So that was something that I've been playing around with as well, that we could actually do. But that would be more for like our Falcon 9 and not this vehicle, which is just trying to, which is basically a lifting body, right? Our Falcon 9 is not a lifting body. If you think the integral thing you mentioned a couple minutes ago might avoid the overshoots, if you can basically go less and less horizontal. Exactly, yeah. How does the rocket know where it is? Because it knows where it isn't, right? Like 100% it knows where it isn't. It wants to be on the pad. It knows it's not on the pad. So it knows where it is because it knows exactly where it isn't. My thought was to come to first approximation for the boost back using PEG, then run it through a numerical trajectory predictor to see where it should actually ends up, then adjust the target in PEG and its predictor corrector system. Yeah, PEG could do that. I definitely think that could work as well. It's definitely a little bit more involved. Like I said, there's so many ways to actually implement this, right? It just depends on like how accurate you want and how much effort you want to put into it. Like for me, I'm pretty happy with just using PIDs because we're pretty regularly getting within 300 meters of the pad. Now, eventually that's going to wear out and get boring for me, and I'm going to want to get it to like land right on the pad like Falcon 9. And so that's when we could probably implement something more robust, certainly. And I do want to implement PEG as well for our either that or UPFG, Unified Power Flight, Universal Powered Flight Guidance, which is what the shuttle used, right? To be a little bit more robust on that ascent profile. Come on, bring it back. I feel like I need more roll control. You know what I also need to do, chat? I actually, on the next go around, should print out our roll to make sure that the sign, because it was right for the plane, but I wonder if it's right for this vehicle. I'm not sure yet. Help with stability control? Yeah, probably. But they'd enhance our stability in this configuration, but then make it harder for us to kick over and get into landing configuration, right? So that's like the kind of thing that we need to find the balance for. The vehicle is pitching up, trying to regulate our downrange velocity, but not able to really do it effectively. It seems like it's rotating in the correct direction, so that's fine. We just might need better roll control in that case. Pointing down towards the pad to try and get it back towards the pad region. That's good. And then now it's going to get into landing zone, landing mode rather. But if it did this before we even like overshot the pad, that might actually be better. Skirt, skirt. Gosh dang it. I wonder if our horizontal velocity controller needs to have more control authority, because it seems like a couple of degrees it has way too much horizontal velocity coming down. But hey, guess what, chat? We're on the pad proper. We are on the pad proper, which is not bad. I once was told an anecdote, probably not true, but when the airline started using autopilot guided landing, they came down on the runway so consistently they were wearing out the runway surface at touch points. So they had to put small random offsets so the wear. Oh, that's actually interesting. The Astra slide, but in reverse. Indeed. Indeed. Could you turn on trajectories for the next flight so we can see a visual of the changing trajectory? Yeah, that sounds good. All right, let's go ahead and reload. And there's a couple things I want to do here. So first and foremost, down here, let's actually increase this to 2. And then let's actually update our control. So this is going to be our horizontal velocity controller. Set max and min. Oh my. Well, how silly am I, chat? Wait, what? Did I really do that? Well, that's an error, if I've ever seen one. This should be heading, target pitch. Pitch is from the horizontal velocity controller. Yeah, this should be way more than just 1 degree. Let's do 5 and -5 and hope that that is fine, but yeah. Is this basically KSP plus KRPC and maybe visual stuff? Does it need much else? No. Yeah, no, it's definitely pretty much that, Teague, for sure. If you want the mod list, I have mods here, which actually, there's one mod missing from that, which is Kerbal Constructs, which is what gets us like the pads and stuff. The issue with me and putting effort into things is I spend so much time thinking about them is I find all the flaws in the approach. Yes, indeed. Yep, no, you just gotta make it happen. Make it happen, Captain, and then go from there. Because that's how I'm doing it, right? Like, we started with like just going up and coming back down for a vertical landing, and then I was like, wow, we're landing consistently like within a kilometer of the approach, so like how can we make it even closer? Then you start looking at like, okay, well, I need like a pitch controller, and then you're like, okay, well, I didn't land near it, but the pitch controller works, so let's implement a yaw controller so we can always aim towards the pad, and you just iterate upon it, right? Iterative development. Very good, yes. So what was the thing that I wanted to try, chat? So we updated that. Gosh dang it, what did I want to implement? Yeah, there you go, Teague. Heck yeah. There was something I wanted to do. What was the thing that I wanted to do, chat? Somebody in chat gave me an idea. Trajectories, yes. Yes, PIDs are only good for specific vehicles, but it works for this one because like the configuration of this vehicle being a suborbital test article doesn't change, which is nice. Gosh dang it, chat, I wanted to implement something. What did I want to implement? The Nums class was actually one of the best. Nice. Yes, exactly, JM, that's true. What were we going to do? Ah, yes, but of course. If Talim altitude is greater than 1500, and then I also wanted to, before I do that, I wanted to print out our roll. So that's pitch input, current horizontal velocity down. Okay, that's fine. Then here I want to do our current roll as well. So this is gonna be vessel.flight.roll. And we'll give it to F. There we go. So I want to make sure that the sign is right here and that it's actually trying to rotate in the correct direction. So we did that, and then I wanted to implement this. So if Talim.surface altitude is less than 1500 meters, if, oh goodness, do I actually have that defined here as well? I don't know that I do. Distance to pad. Okay, we are updating distance to pad. And distance to pad is calculated outside. Yeah, we get distance to pad, okay. Or if distance to pad. But where is this actually getting initialized? Because if it's not here, then that's going to be bad. We have it here, calculating. It was a bunch of weird black magic. So it looks like I'm actually going to need the distance to pad be initialized somewhere. I actually am surprised I don't have it initialized anywhere, because I just have it here. But now that I'm trying to use it in an if statement, then I'm going to need to implement it here, which means I'm going to need to initialize it out here. Okay, that's fine. Distance to pad is going to equal, we'll call it 10,000 to begin with, very, very far away, just so that way it never enters this loop, right? Or it could just be none as well. Or if distance to pad is less than, say, 100 meters. And we could actually probably try to change that based on, yep. Then this is what changes it to be vertical. Yeah, vertical, perfect. Okay. So it should never go here, so then it should enter here, and then it should be updated. I think that should be okay. Because then it should go through in the loop, come back to the top, and then it's checking, so it's always using this as its the last value of distance to pad to check. Yeah. Yeah, I think that's okay. I think that's fine. Primer vector guidance is the RSSRO mode of MechJeb Ascent guidance. Nice. There's also the really robust guidance that Vulcan and Atlas use, right? Which is RAN. Gosh dang it. Does anybody know what that's called? It's they track the RAN, which is why they have such large windows. Also because Vulcan and Atlas can have configurable SRBs, so they can actually have larger windows as well based on the thrust. But it's some sort of RAN focused guidance for the Ascent profile, which is right essentially the ascending node. Gosh, I can't remember what he called it. It was in the last press conference, if I'm not mistaken, from Starliner. So that should all be fine. I don't actually care about this anymore. I don't actually care about heading anymore. Yeah, that's fine. Okay. And I think we'll check that. Okay, I think we're good. Yes, I think we're good. Go ahead and save it, and let's try it again. Checking a lot of matrix map to do cross products? Probably. Generally speaking, yeah, for sure. For whatever reason, that roll control is really not good. I wonder if I can just set roll to nan, or just never even set roll. I think that might work, but anyways, it doesn't actually have to have roll engaged for the Ascent, but anyways, it's fine. You hate matrices? Linear algebra is where it's at. It's where it's at. Oh, Rocket Gal is texting me. Let's see what Rocket Gal is up to. Linear algebra. Yes. Yes, linear algebra. Oh, please. All right, should be going up to an altitude of around an apoapsis of 70 kilometers or so, plus or minus a couple of kilometers. I buy CPUs. Yes, nice. The more CPUs, oh, actually, I guess that's GPUs. I was gonna say the more CPUs you can buy, you can also start mining cryptos. But I guess that's actually more of a GPU thing. I guess it can actually be a CPU thing as well. GitHub, KSPRO, Primer Vector Guidance. Ooh. Is there any papers on implementing Primer Vector Guidance? I'm sure that there is. Is there anything that actually uses Primer Vector Guidance? Uses Primer Vector Theory. It's linearized using Jacobian. Interesting. Are that the indirect method that is used is sensitive to initial conditions and is not usable for dissipative systems. In more plain language, this means that atmospheric modeling is highly problematic to nearly impossible, particularly for any generalized solver that isn't constrained to specific problems. Path constraints like do not go below the surface of the Earth are not feasible to implement. Yeah. Vacuum only optimizer until it's completely rewritten. Interesting. It's good to know the limitations of it. So for one, it's definitely a linearized, optimized system. Uh-oh, what happened? Ah. Wait, did I implement it as none? I thought, okay, I did. And now we die, chat. Now we die. Actually, no, we don't. No, we don't, chat. I can save us. Chat, I can save us. Go to a different script test. I need to scroll up to the top, and instead of test roll, we need to test hover slam. All right, and go. There we go. We're good. We're good, chat. We might land in the water, but it'll be a soft landing test. Actually, wait. Wait. I could do better, chat. I could do better. Manual control. SAS on. We gotta fly it to the pad, chat. We gotta fly it to the pad. We can save this. We can save it. Why does crypto become a large enough energy consumer to become the main cause of global warming? Yeah, because everyone is trying to run massive power consuming devices to try and, well, I don't know, mine it and get rich quick. Oh dear, we are very far away, by the way, but I think we're okay. I think we're fine, chat. N-dimensional arrays or database tables? Yes, yes, of course. OP guide, they came up with it for Constellation, but ditched it for SLS, gotcha. So SLS doesn't use OP guide? Look at us go, chat. Perfect music for this, by the way. And now let's pitch up. Oh, this is as far as we're gonna be able to pitch up, huh? Oh, there we go. Come on. Hold your stuff. Hold up. There we go. Good. Good. Stop. 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 Very nice. That's right. We want trajectories in flight on. Good. Go away. Bring it up. Engage. All right. There we go, chat. Oh, that's right. I forgot that our landing zone is actually not this landing zone for this script, but it should do the landing burn for us. Ooh. Stand by. And enter hover slam. There we go. Tease it. Hit the tree. Yep, tree is good. Tree successfully hit. Skirt. Uh-oh. Oh, God. Oh, it does use UPFG or a modified version of it. Hey, but the crew was safe, chat. Crew was safe. Unfortunate. Unfortunate that was. Okay, well, let's try that again, but let's actually fix the original guidance that we had. Close but no cigar, indeed. Yeah, essentially, in-dimensional arrays. Although, at least nowadays, most embedded systems can actually work with matrices, but they're usually in-dimensional arrays by an in-dimensional vector. But the assessment is still roughly the same. All right, so I think we fixed it now. I think that's fine. Let's go ahead and launch again, question mark? All right, last time that we're launching this. Hopefully it works. Huh. Huh. I'm not gonna lie, that was unexpected. That's our trajectory, by the way. It really did an Astra off the pad. Huh. All right then. Well, that's good. Maybe you should have been more precise. It's all good. Yeah. This is okay. What could possibly go wrong, chat? That's our current calculated landing zone. Oh yeah, I got it. No worries. That's our impact point. Apoapsis of 70 kilometers, hopefully. Although we burned a lot of extra gas. It was not great. But hopefully we'll be okay. And come on, reach shutdown, thank you, perfect. Oh, that's weird. Trajectory's like, nope. That's not how that should work. But anyways, what could go wrong, chat? They ended up heavily modifying the targeting procedure for the B1B so they could actually get valid solutions in case of engine out situations. Interesting. That's cool. Yeah, guidance, navigation, and control is really an interesting topic. Interesting domain. Kerbal being Kerbal, yeah, pretty much. Yeah, I have no idea. Oh, that's what I wanted to see. I wonder if we don't have any target roll set, is that fine? Like, if we never set target roll until later, we have target roll there, but that shouldn't be used. Yeah, I'm wondering if that's like actually not necessary. I don't think it is. I don't think we have target roll set anywhere else until we enter here, and then we have wings level for our hover or for our belly flop maneuver. So yeah, I wonder if that fixes that problem we have on liftoff. All right, almost up. It's called KRPC. It's gonna be even more challenging for just a nerd. Yeah, I understand. Oops, I forgot to turn RCS on. There we go. There we go. So readouts here is we are 5 kilometers from the pad. We are moving backwards away from the pad at 27 meters per second. We are commanding a pitch down of negative 27 degrees. Our heading error is 0.6 degrees off of our desired heading. And then we also have our commanded roll at 0.8 degrees. because it's basically set to align ourselves with the heading. So if we have a very small heading error, then we have a very small roll. And then what was that last thing that I wanted to figure out? That is not it. That is not it. I think it's this one. Yeah. And our actual heading, yeah. Cool. Oh, that's right. Our current roll and then our desired roll. Ah, that's what it is. Our current roll and our desired roll. Those are the last two. Good to know. Glad we refreshed our memories on that. But the distance is increasing for now. But that's because we have to wait until we get into the thicker atmosphere for the lifting body effect to move us forward. So we're pitching down so that way we can pick up some horizontal velocity going towards the pad. But we have to wait for us to get into the thicker atmosphere to do it. So you see, now that we're getting into the thicker atmosphere, we're starting to increase our horizontal velocity. We're starting to move towards the pad now at very, very high rates. And the vehicle's going to do some funny stuff, but it should be okay. Don't worry, it'll come back. There it goes. Coming back into alignment here. And yes, it does look like we are correct in our calculations for our roll control. So that's good. Nice. That looks pretty clean. Vehicle should start pitching up here to try and regulate our horizontal velocity. It will still overshoot, but we'll see if we can't get into a vertical position. If that will actually end up working for us. Once this gets within 100 meters, basically an overshoot, we should pitch over. Is it going to get to 100? Oh no, it's not going to even get to 100, chat. All right, that was a good test though. So now that we overshoot, it's going to command very far pitch down again to pick up horizontal velocity back towards the pad. There we go. Yep, looking good. Now I wonder if it'll go vertical now, if it'll be close enough to do it. Because we should be moving like right over the pad. 100 meters might be too much. Oh, there it goes. That was weird. I don't know why I pitched down there, but it's fine. And engine start. There we go. There we go. All right, brought it back into alignment. We shaved off 50 meters or so doing it that way. I wonder if it would be better to increase our distance to pad to be like 200, since that seems to be 100 meters seems to be really, really close. Or distance to pad is less than, say, 200 meters. There we go. All right, this is the last time, chat. This is the last time we're gonna do this, because I'll be happy with that. All right. Yep, that should be good. All right, here we go. Last test flight. That near tip was scary. Nah, we're good. We're good. Don't even worry about it. So is it going to have the roll issues? Nope, it is not going to have the roll issues. Well, we fixed that as well, chat. How about that? So it doesn't actually need any roll control until it gets to the apoapsis. So yeah, awesome. This is fine. Exactly. Don't even worry about it. Just take a torch to it, right? Just take a torch. Burn it. What is your data sampling rate? Right now it is set to about 10 hertz. So 10 times a second, which actually might even still be too fast, right? Because the game, the actual KRPC API communications with the game run slower because the game is probably running slower, hence the yellow physics tick rate. So you gotta kind of find that happy medium, I suppose. So even 10 hertz might be way too fast, but it's okay. Seems to be working. Eventually I want to start looking at doing some parallel processing, because we could actually have like our burn calculation happen on another thread. So that would actually be pretty good to have as well. How many mods are you running? We are running this many. That and plus herbal constructs. I need to update that command. And by plus, I mean it's like and in addition to Kerbal Constructs. It's not called plus Kerbal Constructs, the mod. All right, waiting for Apoapsis, 72 kilometers altitude. We'll go ahead and kick up to it. Yeah, no, definitely no part mods or anything like that. Pretty much the stock game, other than some beautifying mods and KRPC. Where am I from? Originally from South Carolina, Charleston, South Carolina. Then moved to Space Coast, Florida for 6 years. Now I'm in Colorado. All right, we're in our belly flop mode. We are tracking distance to pad. We're looking good. Your cousins live in Charleston? Heck yeah. So you probably get a real 4 hertz, probably, maybe even 1 hertz. I have no idea. Hurts, don't it? But yeah, it's not fast. It's definitely not fast. In fact, we've even had it where we never put in these sleep controls, and it would completely miss certain updates because the game, like the API, was literally being throttled by the game, and it couldn't actually run the next command line as it was waiting for the game. It was like a significant delay too, like sometimes like upwards of 5 seconds. So then we started implementing a small sleep, and that seems to really help. Unless you're on a toaster. No, but I am only on a single streaming PC setup, so that could also be an issue, right? But no, my PC specs are down below. I think everything's pretty good. We're not at potato quality yet, but this PC is probably now on the order of like 3 or 4 years old. Could be time to start looking for another one and have this be just my streaming rig. I used to have a two PC streaming setup, but my PC that I used to then stream on is now 10 years old, and it doesn't do good. It doesn't do good anymore. Yeah, 10 years old is about the time where it's giving up. It is giving up. All right, looking good. And then it's going to start not looking good. Now it's very much not looking good. But recover, baby. Come on, recover. You can do it. There you go. Roll, baby, roll. Roll towards the pad. There you go. Come on, bring it back. Bring it back. Ah, there we go. Whew. It works or not, still rocking the 660-100. Yeah, that's nice. All right, we are tracking. We are looking good. Hopefully we'll get within 200 and then go into landing mode, question mark? Maybe? I don't know how easily it's going to do this. Like I said, we're testing this part. I don't know how well this will actually work. And there it goes. Should go into vertical. Trying to bring us back towards the pad. Ooh. Ooh, that might not be the right move, chat. Okay, going into landing mode. Yeah, that may not have been like the best move, but we're okay. So it might even need to be like farther out. Like if our horizontal velocity is greater than a certain amount and their distance is this, then basically go vertical. Not bad. Oh man, really? Shame. You did VR without overclocking? Nice. Nice. Not bad. Bummer. Just like the Real Thing, chat. If you guys don't know, the Real Thing did this. Actually, it's the exact thing. DCX failure flight. Really, really unfortunate. See if I can find it. I think it's this one. Yeah. Try this one out. So yeah, this is the DCX vehicle. This is the real life analog to what we built in KSP. Beautiful machine, chat, designed to test suborbital trajectories, basically, and reusable landings back in the 1990s. Way before SpaceX, they were looking at being able to do this for a launch vehicle. And so vehicle is coming in nice and easy. Everything is looking great, looking solid. It changed my KSP skill so hard. Indeed. Yeah, I actually have one. I keep forgetting to put it back in. But yeah, Bonafide is pretty great. Look at that. Look at that beast, chat. And it's hovering. It's at apoapsis. Notice the smoke trails, right? It's now falling. So basically, this was designed to do almost exactly what we're doing in KSP, which is to fly straight up. It would then hover for a second, start falling, maybe kick over to a different pad, and then go into a landing configuration. So out of 1,000 feet, there's landing leg deploy. Notice one landing leg failed to deploy, chat. See how there's two over here, but one over here? And so then it lands oh so perfectly, chat, so smooth, like SpaceX. And then sadness happens. And then the program was canceled. Ah, yes. Yeah, the RL-10s. Those are RL-10s indeed. What's the end goal? Land on the pad. So now that we've kind of gotten this to a point where it could be certified for flight, what I would like to do is put Kerbals in it and use it as a test flight vehicle. So that way we could send them on suborbital flights and get their experience up. That's kind of what I'm hoping to do. But I wanted to do a little bit more work with it so that way this doesn't happen, right? I want it to be where this doesn't happen. They could walk away, not a failure. That's true. But also at the same time, kind of sucks. Kills millions in contracts. Yep, that's pretty much it. Really unfortunate. All right, let's go ahead and recover that. Because we have some planning to do, chat. I will have to go here soon-ish, but we have some planning to do. We need to figure out what kind of vehicle that we want to implement for our crew rating. Do you have an end goal for this project, like a fully automated mission? That would be great, Atlas. Yes, I do want to get to that point. I kind of have many goals, right? Because one big goal would be to like fully recreate like a Falcon 9, right? Go up, separate second stage, have the first stage turn around, boost back to a landing zone, and then come in for a landing and ideally hit within, say, a couple hundred meters of the landing zone from an orbital velocity, right? That's one. I also want to implement an automated docking controller, which actually should be really easy. Well, I say really easy, but yeah. Want to be able to do that, want to implement, I basically do want to have like an entire library set up to where we can pretty easily do like fully automated missions. So we're doing it step by step, of course. Step by step. Yep, history repeats itself, of course. All right. Yeah, let's go to our space plane hangar. Like I said, we have a number of vehicles to choose from to implement a crew rated vehicle, because it is kind of getting into the point of the save where we should start looking at crew vehicles. So let me go to I2 orbital because we have one there. Moon mission, yes, let me find the script, indeed. So for a crew vehicle, we have a shuttle that we could use. Somewhere in all these craft files. Somewhere. At the end, isn't it? Yeah. Not that one, though. This one. Yeah. So we have this little guy. Don't worry about this. This was used to pull it up on a crane. But yeah, we have this little guy known as the... This is actually based on a real vehicle called the Crew Return Vehicle. If you guys don't know about the Crew Return Vehicle, it was a lifting body design actually contracted out by NASA, known as the X-38 Crew Return Vehicle. And again, this was another fantastic fantastic contract that was well, canceled. And yeah, so the Crew Return Vehicle was meant to be a, well, just that, basically an emergency escape pod from the International Space Station to carry crew home. And yes, it did actually land under parachute, under paragliding, which is actually pretty gnarly. But it was a lifting body to help it, you know, navigate going through the atmosphere and then coming into a nice easy skid on a runway. Why? Because the parasail was actually controllable through automated controllers in the actual vehicle, which is pretty crazy. So that was actually really interesting. We of course have a Dream Chaser that we can use, but this is a nice little tiny vehicle that's designed to go up on a pretty small class launch vehicle. We have that one at our disposal. Going hypersonic in flight sim is insane. Oh, I bet. The scram kicks in, yeah. So we have that one. We of course have many from i2 Innovations. I know, right, Bonafide? That is true. That is true. It used to be so innovative. Yeah. Well, it's coming back. Now it's just more commercial oriented, which is fine. We, of course, have our STS. We could implement the space shuttle as part of our crew return vehicle. There we go. We have this that we can work with as well. It is nice, chat. I do like our STS. There's even a few upgrades that we can make to it that I think we never finished. Yes, we also have our STS program. We could implement this in our save as well. We, of course, chat, of course, we have our Clipper shuttle, which is an i2 innovation. Ooh, man, if it'll load, though. Doom, doom, doom. Doom, doom, doom. There we go. Let's see, where is Clipper? Oh yeah, we have our Dream Chaser. We do implement a Dream Chaser as well. Like I said, there's a lot to choose from. It just depends on what we all want to do. Where's the Clipper shuttle? That's STS. Do I have the Clipper? I have to have the Clipper here. Yep, there we go. Clipper. Do I not have one with a thumbnail? No? Okay. Kerbal Clipper, Dev 7, external tank expendable. But what are your thoughts on KSP2 being on the chopping block? I really hate it. I really hate it. Wow, that's the old one, chat. Holy cow. This is the old Dorito plane. Where's the new hotness? Yeah, it really sucks, Bonafide, 100%. Like, I was really looking forward to this next patch that they were about to push, because it was supposed to fix a lot of the kind of like quality of life problems that they were having. So yeah, really sucked. Is it one of these? KTS? I think it's KTS Mark II flight ready. But this one? What's KSP2? Yeah, exactly. Ah, yes, here we go, chat. So yeah, we have the Dorito here. Our Dorito launch vehicle. Carries a crew of 7. Also has a pretty large cargo bay capable of around 30 metric tons to orbit. So that could certainly be a shuttle that we implement in our save. I know, right, Thailand? I actually kind of liked where it was. I kind of like where it is right now, but there were a few quality of life problems that they were having, which is like, you know, so it was a pretty common problem to have your orbit lines disappear, so you couldn't actually do any sort of node planning and stuff like that. That was really upsetting, and that was supposed to be fixed on this next patch that they were literally just about to release, which kind of sucks. Star Clipper! That's right, indeed. One of the only two good things that came out of the 1990s. Yeah, I know. So we of course have those. We have Dream Chaser. We have the Dragon Capsule. Here's our Dragon Capsule. Complete with unpressurized cargo space. So we have the Craggle Capsule. What do we want to use, chat? You guys leaning one way or the other? Might be good just to start with something small like the KRV, the Kerbal Return Vehicle. Basically the shuttle that I showed y'all at the very beginning. And then we can scale up there as needs persist. Let's see, what else do I have at our disposal? We of course can do a simple pad. A simple capsule, something like Starliner as well, or even Orion. Here's more of the Dragon vehicle. I think that's about it. Soyuz 2B. Yeah, for the most part, that's it. I'm sure there's some others that we can find to use as well. That just doesn't have a thumbnail that's easy to find, but yeah, there's like a lot of things that we can use. Open source KSP, that would be really good. What's up, Pato? How are you? I had an issue with wheels being pushed under the ground, thus not moving, even though they're on the ground and not drag. Interesting. Interesting, yeah. Yeah, there were a few things that they were trying to fix, though, for sure. Yeah, what do you guys think about using the KRV, or what we call the Mercury vehicle? I think we might go with that. Yeah, I think that actually might be good. So let's actually go into I2 orbital. The last bastion of greatness, yeah. Yeah, so the X-38 would be pretty good. With pad abort. Yes. Load that in. We don't have a grip strip. Oh yeah, it's these guys. That's fine. Everything else should be stock though. Or everything else should be doable right now. Yeah, I think we'll use this, chat. We should do a test flight of it though. Get rid of you, get rid of you, get rid of you. Yeah. That seems fine. I have no idea how much lift this is going to create for our vehicle, but it should be fine, right? Totally should be fine. Oh, interesting. Interesting, JM. All Unity games are kind of open source? I suppose that's true. All right, let's go ahead and save. That's going to be the X-38 with abort pod. If I could type, that'd be great. Something like that. Okay. Let's go ahead and save it. Let's get our staging right. Also, we need the abort sequence for action group. I hate as much as I love, they just leave it alone and let the community flourish. Yeah, indeed. RIP. Yeah, it should be good here. OBS doesn't tell me any problems. Back? Refresh works? OBS says I'm good. There's a 5-second rip, gotcha. Interesting. You see? OBS says I'm good. I don't know if Twitch just gave up or not. Totally died? Well, obviously, yeah, okay, interesting. Well, fair enough. We're back though. We're back. We never went anywhere, chat. I swear, we never went anywhere. All right, let's figure out what we got here, chat. So I think this should be good as is. We were checking out the action groups. So we need an abort, Twitch being Twitch. Yeah, probably. So that's the active there, decoupling there, and deploying there. Awesome, that should work. That should work well. Nothing to see here. Go right along, move along, chat, move along. Yeah, so that doesn't need to happen. Actually, does it? No, that doesn't need to happen. That doesn't need to happen. These are only the aborts. So that's good. That should work. And then we need that. Wait, does this not actually have... Ah, it does not. Ooh, do I have another action group for that? So abort does that. No, I don't have another abort then. Okay. Fair enough. We got bored with grinding missions for money. Normal was more fun. Hey, there you go. There you go, Varinky. I definitely play my hardcore career a little bit differently, probably, because what I do, because we have so much experience in the game, I start with like everything except for the last tier of research unlocked, so that way we can actually get into the big rockets right off the bat, so that way we don't have to do like the whole silly like, oh, here's a thumper, put a crew capsule on it and launch it, and I hate that. That's not fun. Not fun for me. So yeah, I think we started off with like 500,000 Kerbucks, and we started with like 2,000 science, however much it is to get all the way up to the level 2 research facility science. All right, we separate from there. Separate that. I need this to actually be on enable staging. Yeah, that looks good. So now we have that. Yep. That's already going to be gone. That's going to go. I do want, let's see here. Oh, but that does need to go actually first. All right, I'm just making sure our staging is fine. So yeah, we have that. That's going to need to happen first. Then that. That does not need to happen there. We are going to want all of our engines active though. Be down here before separation. Yes, good. Then separate, then that, then that. Yep. Okay, that seems good. Let's go ahead and save that. Let's get our vehicle out, our launch vehicle. So our launch vehicle is going to be from Spaceworks. It's going to be our Minerva, flight ready. We are going to need a new variant of our Minerva. Take you off. This is going to be Minerva 1 plus Mercury shuttle flight ready. Save. Okay, and now we can go into here, load it up, and then we want the Mercury shuttle with pad abort, merge. Perfect. Heck yeah. And then from here, take you, edit fairing, bring it in. Almost. Okay, too much. There we go. There we go, chat. And save. Cool. Let's go ahead and save that. Let's go ahead and switch editor. Bring it up. Do that. Make sure no Kerbals are on board. Jeb, get out of there. Save, and we're going to do a pad abort test real quick, chat. Because I have no idea how this is going to go. Launch it. So yeah, pad abort test would be great to see. I'm hoping that we have enough Delta V in the abort pod there to get us away from the vehicle nicely. That was weird. Okay, fine, I guess. All right, chat. So SDS on, and then in 3, 2, 1. Boop. Perfect. Absolutely perfect, chat. Loved it. That was exactly, look, the crew is safe. Crew is safe, chat. See what I mean? Crew is safe, not a problem in the world. I think our control point was wrong. Let me tell you what, chat. I think our control point was wrong. Jeb certified. Walk, don't run. Yeah, exactly. I would just do a quick revert here. Because I'm thinking our control point was wrong. Putting that out there, I think. Yeah. Yeah, for sure. 100%. So I think what I actually want to do here is come into this real quick, if I can, and change. Let me see, what do I actually need to aim at? Parts, aim camera. Wherever our control point is for this vehicle should be around here somewhere. Let me actually now aim camera here. There it is. All right, part, configure vessel naming, lowest priority, it's a probe, accept. And then if we go up to here and aim camera, do I have a control point somewhere nicely up here? I don't know why I have that. Command pod could be it. I think I have a better control point somewhere. Ah, yes, there it is. Part. Configure vessel naming. Tallest point 20, accept. Good. Okay. Now I'm hoping what that means is that now when we separate, this will actually be the correct point, especially if I control from here. All right, let's make it happen. So, SAS on, and in 3, 2, 1. Hey, there we go. Look how stable it is, chat. Wow. Heck yeah. Oh, I don't know why we're controlling that, but anyways. I feel like my control point is incorrect here. Yes, my control point is once again incorrect for some reason. Okay. Oh my god, game, please stop freezing. This is fine. Control from here. There we go. There we go, chat. This is fine, right? So what I really like about this vehicle is that we made sure that the flaps are actually in a deployed configuration and then gizmoed to be level. So that way they only actuate in one direction, which is exactly what the real thing would do. They're basically body flaps, right? The top only actuates up, the bottom only actuates down. So that's pretty nice. And like the real thing, don't forget, chat, this actually originally was supposed to come in under parachute, and so of course we're going to come in under parachute. As soon as we line up with the runway. Because unfortunately we don't have parasails in the game unless it's under Kerbals. And there we go. I wish we had parasails in this game. That'd actually be really awesome. Boop. There we go. Yeah, I like it. This is what we're using, chat, for our crew missions to low Kerbin orbit. I think that's what we're gonna do. Yep. But anyways, chat, unfortunately it is 1:30. I'm going to have to head out because I have to get lunch started. The wifey is coming home soon from work. So yeah, chat, hope you guys enjoyed the stream, enjoyed the improvements we made to the DCX vehicle. We should be streaming next time, and hopefully we'll lock in the DCX vehicle to the point of certification flights, and then we're going to put crew on board and test that. Not only that, but we also have to start looking at launching this guy. This is what we're gonna have to try and figure out how to launch here soon enough. Why? Because we actually already have some contracts for some Kerbal missions to actually do some spacewalking in space and all that jazz. So, what's up, NASA man? How are you doing? Coming in right at the end of the stream there, but no worries. Doing good, most excellent. But we are heading out. So, next stream might be tomorrow. Unsure about tomorrow, but we'll definitely be back on Monday. No matter what. That is our current streaming schedule, Thomas. And so we should be back. So have a wonderful Sunday. If I don't see you, have a good rest of your Saturday. And we'll be back here soon enough.